So just to review again, di ba, ang classification ng fungi natin is either following the botanical taxonomy. Ano yung mga groupings ninyo sa botanical taxonomy ninyo? Uy, gising na kayo, di ba? Ano yung ating botanical grouping? What were the different botanical groupings that you had? Mikey? Botanical grouping?
Glomeromycota, Ascomycota, Basidiomycota, saka Deuteromycota.
Okay, thank you. So, yun ang classification natin. And then, as to the type of mycosis, we already have Israel, are you there? Type of mycosis. Hindi ko pa pala na-print ang inyong class list. Asan si Israel? Kita ko pumasok na kanina. As to the type of infection, ano yung grouping natin? Brandon.
Afternoon, ma'am.
Okay, type of
Hello po, ma'am.
mycosis. Ah? Classification according to.
Hello po, ma'am.
Yeah. Sino to?
Israel po, ma'am.
Okay. Type of mycosis according to infection.
Superficial, subcutaneous, systemic, and opportunistic po, ma'am.
Okay. So you have your superficial and cutaneous. You have your subcutaneous, systemic, and then you have your opportunistic. So, yan lahat ngayon titignan natin. Paano ba natin malalaman whether yung ine-entertain natin na pathologic agent of disease na fungi ay ma-identify natin. Of course, we always start with what? When we're trying to identify an organism. Since pagpunta ninyo sa hospital on your internship, napapansin kasi natin na bakit walang mycology. Lahat ng sections, of course, you have the different sections and then walang specific section for mycology. Although alam naman natin that it is under microbiology kasi bacteriology is already also a part of microbiology. So that yung mga modern modern clinical laboratory, kailangan din nila mag-provide ng methods kung paano ma-isolate at ma-identify yung mga common causes ng mga iba't ibang fungal infections. The thing is, kasi ang most common fungal infections, di ba sabi natin dun sa intro natin, is that common fungal infections, of course, you have all of these superficial infections or our subcutaneous infections, which doesn't really need usually laboratory identification or any laboratory procedure to identify the presence of the fungal agent. But nevertheless, ang mga ibang laboratories, syempre, they have to upgrade or they have to, ang tawag natin doon, ay yung follow yung mga modernization ng iba-ibang laboratories. Pero syempre, we all know that the cost of putting up, a special laboratory, especially for mycology, medyo mahal na naman yan. And of course, also, the personnel, the safety, and all of those. So that, when doing the laboratory identification, if you went through your module already, so that we need a biological safety cabinet class 2 for the inoculation and manipulation to avoid getting contamination or to avoid laboratory-acquired infection, sabi natin earlier. Now, ano yung recommended? So, di ba, ano yung mga recommended ba? When we're talking of biosafety practices in the laboratory, lahat ng gamit mo dapat would be able to cater to that. Di ba? So that recommended kasi is that the use of screw cap tubes. Ang inaano kasi dito ng screw cap tubes is that it will eliminate the accidental release of spores. Diba? Ano yung tatlong mode of transmission natin with fungal infections? 3 modes of transmission. Charlene? Sakit talaga ulo ko. Napipikit yung aking mata. Ayaw mag-open ng mata ko. Shirley,
Ma'am.
review the 3 modes of transmission ng fungal infection.
Person to person po, animal to person. Tapos, ko na maalala yung isa.
Okay. Ay, yung depende yan kung ano ba yung risk na napopose niya to the individual, to the community, and whether meron ba tayong mga treatment na available na if you get an infection with that pathogen or the fungi. Okay, yun ang basis ng risk grouping. So that here, sinasabi na si Coccidioides species and our Histoplasma capsulatum, they belong to the risk group 3 pathogens na ibig sabihin niyan, hindi rin sila pwedeng i-manipulate or maggawa ka ng inoculation mo with Coccidioides and Histoplasma sa Biosafety Cabinet Class 2. Kasi kailangan mo ng higher level ngayon ng Biosafety Cabinet, higher level ng iyong Biosafety Cabinet. Although, the biosafety level, again, here requires already to the laboratory. Ang mga biosafety levels kasi mga academic laboratories, okay na ang biosafety level 1. Okay? So, yung mga biosafety level 3, yan na ngayon yung current na ginagamit para sa ating COVID-19 virus. Okay? So, that is to laboratory safety. Siyempre, pag when we talk about the laboratory safety, is that it covers everything from the collection to the processing of the specimen. So, dapat lahat yan, ang priority natin in the laboratory would be not only your protection, the protection also of the environment, and the protection of the pathogen you're working on. Okay? So, as with your bacteriology, laboratory identification, sabi ko nga kanina, always starts with your specimen collection. And when we're talking of specimen collection, nagle-lecture ako, nakapikita ko. When we're talking of specimen collection, is collecting the proper sample also at the right time from the appropriate site. Hindi ka naman basta kumuha din na I have in and which most of them naman are slow growers. Pero meron pa din tayo ng mga fast growers na fungi. So, yun lang ang medyo inhibit natin ang growth. Now, for when it is with entertaining oropharyngeal candidiasis, and we already can do a direct smear and then culture. Now, we have the chrome agar candida or the candida ID, which is specific for growing our candida species, wherein you will be able to distinguish it to this species level kasi nagproproduce sila ng kanilang color using your chrome agar candida. Okay? Now, for the other specimens, like for CSF, alam niyo naman na kung pag CSF ang specimen natin, you know the method of collection. So that pareho din sa bacteriology, kailangan lagi yan i-concentrate. For the main reason din na kung isipin natin, kukunti kasi usually ang pathogen na nandyan. So you need to concentrate what are the modes of concentration. You can do it by filtration. Kasi pag finilter mo na, pwede mo nang gamitin yung filter paper na yun ang ilalagay mo dun sa Petri dish. Or you can do centrifugation. So that with your CSF, the culture should be examined daily. And then the volume, of course, is less than 1 ml of CSF. You centrifuge to get a drop of or an alicot of that. And then yun nang ilalagay mo sa iyong agar surface. Now, with CSF, of course, we know it's sterile. So, sabi natin dito, it should contain no antibacterial or antifungal agents. And as it is, CSF should be processed promptly. Sabi natin, pag CSF, ASAP lagi yan. But if not possible, it should be kept at room temperature or incubator at 30 degrees centigrade. Now, pag CSF, usually ang sample, especially when we're entertaining cryptococcal meningitis ba or encephalitis, uh, ginagawa na yan ng India ink. India ink or latex agglutination or yung sa latex agglutination or yung cryptococcal antigen. Kasi pinalitan na ni latex agglutination yung usually ginagawa na negative staining for cryptococcus kung present man siya sa cerebrospinal fluid. So with the rest, you have your blood and then you have also your hair and skin. Alam niyo naman na yung sa blood. So for the hair and skin, which is for dermatophyte culture, the sample collection, I hope you went through the different videos na inilagay ko dun sa module ninyo. Pinapakita kasi dun kung paano ginagawa yung collection or paano ginagawa yung mga iba't ibang procedure sa laboratory identification. So for sample collection, of course, before you collect anything, any sample, di ba, you always have to first clean the area with 70% isopropyl alcohol. Same with the nails. Yung nails kasi usually hindi lang yung superficial, yung top layer ng nails pwedeng scrape mo na and then you take. Depende kung gaano ka-infected yung nail. And din doon sa skin scraping naman, so you scrape the outer border of the skin kasi yung movement kasi ng fungi parang lumalabas siya. Kaya napapansin niyo pag fungal infection, if you have had experience having one, then nakikita niyo merong elevation doon sa border habang palaki ng palaki. So yung border na yun ang i-scrape ninyo. Yan ang sample ng ating skin scraping. Pag hair naman, pwedeng i-cut yan ng sterile scissors, but the best one is still plucking with forceps. Of course, sterile din yung forceps mo. Now, for hair, skin, and nails, hindi kailangan ito ilagay sa refrigerator. So, ano ang gagamitin nating media when you have your pinagsama yung skin and hair? Pag ang specimen natin ay hair, skin, and nail scrapings, so even if we say that the general isolation or the general or primary media for fungal isolation or fungi isolation is your SDA, pag dermatophytes na, we have also your microbiotic or your mycocell agar or we have other DTM agar din, medium din for dermatophytes or dyan sa ating hair, skin, and nails. So, we have different methods here that are placed na rin kung sa wood slump kasi pwede mo munang i-check kung mag-fluoresce yung hair para yun ang ipipick mo o yun ang ipa-pluck mo. Then, for the vaginal specimen, these are transported to the laboratory within 24 hours of collection using, of course, your culture transport swabs. And then, they should be kept moist. Yun ang purpose bakit sila nasa transport swabs for the wet preparation so that you can use now selective and inhibitory agars for the plating of the specimen. Now, the culture should be screened for yeast kasi anong in-entertain natin dito? Is the yeast for candidiasis. Incubation is 30 degrees centigrade for 7 days. Urine process ASAP din. Bakit? Bakit kailangan i-process ASAP si urine? Ito na yung aking listahan. Dave, as it of first honor ka ngayon sa sa pagpasok sa klase. Dave Ikin.
Yes, ma'am.
Bakit kailangan i-process natin kaagad si urine?
Ma'am, kasi pa habang tumatagal, di ba ma'am, mas tumataas yung concentration habang tumatagal.
Bakit tataas ang
Ay,
concentration
di
ng
ba na,
alin?
nung urine po.
Bakit tataas ang concentration ng alin? Yung urine mismo?
Ay, hindi po.
Ano meron sa urine natin? At kailangan natin siya i-process ASAP. Kahit sa UA, di ba nag-AUBF na kayo? Di ba nag-analysis of urine and other body fluids? AUOBF. Ang haba. Di ba ayoko na, urinalysis na lang. Analysis. AU. AU.
Ay,
Di ba
ma'am,
nag-AU na kayo?
Yes, ma'am.
Yes, ma'am.
Anong meron ng urine? Kahit sa AU, kailangan yung i-process kaagad yan.
Baka po makontaminate ng mga gram-negative bacilli. Ay,
Paano
bacteria.
napunta si gram-negative bacteria doon?
Yun po, nabasa ko lang po kasi due to oftenly contaminated with gram-negative bacteria.
Hindi What is present in your urine? Where does your urine pass through? Kasi di ba kanina natin, pag yan, sterile ang iyong specimen coming from sterile sites, no need for antibacterial or antifungal agent. Urine. Di ba ang dami niyang bacteria? It passes through a lot,
Yes.
bago siya maiihi natin yan, meron na siyang bacteria. You have your normal flora with it. So that you wouldn't like or you wouldn't want an overgrowth of the bacteria dun sa urine. Kaya kailangan din natin siya i-process agad-agad. Okay? So, kaya dyan din ang sinasabi lagi pag urine ang specimen, best yung iyong first voided morning urine specimen. Ano ang mode of collection nyo? Mode of collection. Mode of collection. Alfred. Si Alfred. Alfred present, absent.
Present, ma'am. Present.
Bilis mag-present.
Ma'am.
Ano? Mode of collection. Siyempre, ma'am, iihi mo, micturition or urination. Sabi mo, ano yung specific, ng pag-urine ng sample? Wala lang. Ano yung kinakatch natin? Keep.
Midstream mo.
Midstream catch. When you're talking of urine, you have, syempre, a method of collection, of course, is micturition or urination. Pero then what do you need to do with pag-urine ang sample? You always get the midstream catch. Why? You eliminate pa rin yung bacteria dun sa una at sa huli. Okay? So that nakalagay dyan na antibacterial agent should be added to media to ensure the recovery of fungi. Otherwise, pag wala siyang antibacterial, natalo si fungi ni bacteria. So with the tissues, bone marrow, and sterile fluids, usually ito sa histopath. Siyempre, pag tissue, meron ka munang kinuha na sample through surgery. You have your bone marrow and still your sterile body fluids. So, same with your histology. Anything that concerns specimen collection, paulit-ulit lang sa mga subjects ninyo na nangangailangan ng specimen. Pag abscess naman, of course, pag abscess, paano kinokollect yan? Or meron kayong wound exudates at paano kinokollect? Tawagan ko Dorina, sabi niyo. Faye Shimea Beran. Ano si Faye? Faye? Present, absent. Present, absent, tulog. 1, 2, 3. Hindi kasi nag-exercise si Faye kanina. Faye? Absent si Faye.
Ma'am, present daw po siya.
Nasaan siya?
Nag-chat siya po, ma'am, dun sa
Ang bilis Ang bilis ng, ang tawag dyan? Asan ang chat? Dalawa kasi ang ko. Sige, bakit? Ano nang tatanong ko? Ano ang mode of specimen collection pag ang gusto nating sample or specimen ay abscess or wound exudate? Sino yung sumaluki aspiration po, ma'am. Okay. Yun lang pala, ganun lang. Ipindot ko lang. Okay. Thank you, Faye. So, hindi absence phase. So, we do aspiration. And then, this can be plated directly onto the media. Okay? So, dito papasok yung mga mycetoma, yung mga ganyan. You have to examine the fluid or the exudate with the presence of granules. Now, this was lifted up, nakimehon ito. So, you can see kung saan ba, anong mga samples anong specimen ang best na re-recover natin yung fungi na nagkukos ng infection. So, nandyan siya. And this is also in your mayhon. And since everyone have said they have the mayhon, so you can just go over and review it too. Okay, so again, this is your algorithm so that you have collected your clinical specimen. Anong clinical specimen? Pwedeng sputum, pwedeng CSF, pwedeng blood, pwedeng hair, skin, and nail, pwedeng tissue, pwedeng bone marrow, pwedeng anything that would represent or where the fungi could be isolated. So you have that. Dalawa ang gagawin mo. You can do your direct examination. Pag sinabi natin direct examination, ano yun? Paano mo gagawin ang direct examination? Tapos na si Israel. Chi! Layo ni Chi, nasa Isabela. Chi, paano ang direct examination? Josh. Inaayos
So, ma'am, ayan, ma'am. Okay na po.
Okay,
Ma'am,
inaayos
bali
pa
ano
ni
na
Chi
po,
ang
ma'am.
microscopic
Microscopic examination na po.
ang sa
Yung direct examination po.
microscopic lang siya ba?
Ma'am?
Microscopic lang pag direct examination? Di pa pwedeng macroscopic and microscopic?
Pwede po, ma'am.
Okay. Sige. Pag culture.
Okay po.
Pag
Ay, ako pa
culture,
rin.
Chi, ikaw pa din.
Ay, ako pa rin, ma'am.
Oo.
Culture. Makikita niyo naman po yung rate of growth. Ganun niya po, ma'am.
Okay. So, especially, di ba doon nga, sige, growth rate and all of those already, you go back again to the colony morphology and all. Most especially yung kanilang temperature, di ba, that para makita natin kung, makita mo na agad dun sa culture yung meron ka ng idea kung ano yung fungi. Nag-grow ba siya sa ganitong temperature o hindi? Okay? So, yun sa direct examination ninyo. And then, we have different methods of doing that. So, ito yung sa growth mo. Alam nyo na yan. Later on, you'll get into that. Alam nyo na pag siya ay yeast at alam nyo na kung siya ay mold. Now, talking about again the temperature. Kasi, di ba, para hindi kayo malito yung sa dimorphic fungi natin. That they can they can grow at different temperatures. So, that yan tinatawag natin na thermally dimorphic. Kasi kung maalala nyo, meron tayong present earlier dun sa introduction about a fungi exhibiting two forms in one culture, which means na dun sa isa lang yung pinag-anuhan mo sa kanya na environment niya, na condition niya, pero na-demonstrate niya yung dalawang phases, yung mold at saka yeast phase. Okay? So that we specifically say thermally dimorphic yan when you're talking about growing at 22 to 25 and another one na mag-grow din siya at a higher temperature which is the 35 to 37 degrees centigrade. So pag yeast yan, anong titignan mo? Pag nag-grow, then you check already for germ tube formation, then you can also do your biochemicals. Sa mold kasi parang mas madali silang i-identify. Kasi magkaiba yan. Si yeast, hindi masyadong helpful yung macroscopic. Kay mold, importante na leading na yung macroscopic niya. Kay yeast, kailangan mo ng identification nila is more sa biochemical test. Sa mold, pwede na yan. Okay, nakita mo macroscopic niya, mag-microscopic ka na lang, tignan mo lang yung mga structures. Meron ka ng identification. Okay? So, yan yung ating algorithm so that you can go back to this later on. Pag binigyan ko kayo ng case, iti-trace nyo lang, tapos alam nyo na kung Sa cornmeal ba, nag-produce ba siya ng blastoconidia, chlamydospore? O sa iba, kasi meron din tayong general agars, meron din tayong differential agars sa mycology. Okay, so culture media and incubation requirements. So sabi nga natin kanina, you should be able to select din. Sabi ko nga, meron tayong general purpose agar, meron din tayong selective, meron din silang differential. So that pagpili ng media, although we say that the general purpose media, kasi sabi ko nga kanina is your SDA, ito yung commonly used in the laboratory. Pag walang SDA, potato dextrose agar. So less common kasi si Amons saka yung inhibitory mold agar. So pag may sample ka na, i-inoculate muna yan natin sa SDA. So you again check for the macroscopic characteristic. Anong macroscopic natin? Of course, you look at the colony. Ano ba ang description ng colony according to its topography and according to its texture. And aside from that, also according to the pigmentation, wherein malalaman nyo later on yung sa pigmentation, kailangan sa reverse kasi pag sa top view mo, pwedeng natatakpan yan ng kanyang aerial mycelium. So, ang recommended battery of media nyo is, as mentioned earlier din, one that should have and one without cycloheximide. And one media again with antibiotic or the antibacterial agent and another one without. Okay? So, ganun yung sa pag-select natin ng nawala siya. Okay. Pag-select natin ng ating media. Now, babalik naman tayo sa agar plate or screw cap agar tubes. If you went through, if nabasa nyo both books kasi Bailey's would go for the agar plates. Bakit mas gusto ni Bailey ang agar plate? Kasi mas madali siyang i-manipulate. Imagine niyo yung, di ba pag nag-open kayo ng tube, ang small ng opening niya. And then, aside from that, ang hirap din ng isolation, ang hirap din i-describe ng colonies na magpo-form sa tube. Ang advantage niya kasi is that, since screw cap siya, and then konti lang yung media niya doon, mas lessened ang dehydration. Nakikip yung moisture. Whereas kung plate ang hawak nyo, you were able to experience naman holding a plate, opening a plate, it's much easier to manipulate. The only thing there kasi nga is yung evaporation din ng dehydration ng media. Although this can be eliminated kasi nga pwede mo nang balutin si Petri dish mo o i-seal yung opening ni Petri dish with the Petri film. Doing that, syempre ma-preserve yung moisture ng media. Aside from that, ma-eliminate din natin yung escape ng spores or when you get to the lead lifters na lagi natin tinatawag sa mycology, hindi rin malilift yung cover niya kasi nga nakaseal naman siya so magkadikit sila. Okay? Now, bakit 40 ml ng agar? Ilan yung ml natin sa bakte noon? Ideal volume ng ating bakte. Kevin Talon. Where's Kevin? 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 Wala si Kevin. Walang sumasalo kay Kevin. LM, Kamayang. LM. LM. Magkasama si Kevin tsaka si LM. Okay, Jude. Judrick. Tatlo na sila magkakasama, si Judrick, si LM, tsaka si Kevin. Junavie. Junavie?
Hello, ma'am.
Ano yun, ml ng ating media noon sa bakte? Maalala nyo pa?
25, ma'am.
Yeah, 20 to 25 ml. Sa fungi, sa ating mycology, dapat yan at least 40 ml. Bakit 40 ml? Bakit kaya 40 ml? You know, I was thinking about this. So, tapos binabasa ko, pati si Conman lumabas. Binabasa ko 40 ml of agar. Pero nakita ko siya somewhere. Bakit 40 ml? Genevieve. June. Navi. Bahin natin. Godwin. Umayam. Godwin. 5 na sila. Magkakasama si Kevin, si LM, si Judrick, si Godwin, Umayan. Makakasama pa si Godwin, Tabalbag din. Ay, hindi.
Ma'am.
Kasama si Godwin, Tabalbag. Bakit kaya 40 ml ang ating kailangan na agar sa micro?
Ma'am, para siguro sa vegetative height.
Okay, naisip ko din yan. Because, di ba, meron tayong pababa, meron tayong pataas, you have your reproductive, and your vegetative. Now, another one is, ewan ko, nabasa ko, hindi ko alam kung kaninong book ng microbiology, is yung kasi nga sa, di ba sabi natin, to avoid the dehydration of the media. So, the more the media, the less, the more ba ang ano natin, ang correlation nun. So, yung dehydration niya is hindi kaagad mangyayari, parang ganun. Okay? So, the moisture is kept. Now, you have a bigger volume of the agar. So, the addition of the different antifungal and the antibacterial will, of course, give you better growth of the fungi you're trying to isolate. So, ano yung mga combination? Pwedeng 5 micrograms per ml ng cyclo, plus 16 micrograms ml ng chloramphenicol and the rest. Okay? So, ano yung mga ating pathogenic fungi that are partially or completely inhibited by cycloheximide? So, you have your Neoforma, you have your Crusade, we have the Trichosporon, you have your Pseudolascaria boydii, and the Aspergillosis species. So that if we are trying to isolate these fungi, syempre hindi tayo maglalagay ng cycloheximide kasi hindi na siya tutubo, wala tayong ma-isolate. Okay? So, incubation. Again, let's get into the temperatures. You have your 25 to 30 for 21 to 30 days and examine at least twice weekly. Anong sinagot nyo sa multiple choice kanina? Kung gaano katagal dapat ang culture media nyo bago nyo i-dispose o bago nyo sabihin no growth? Ilan ang sumagot ng 78 ba yung unang choice doon? 72. 72 hours. 72 hours, 2 weeks.
72 hours.
Ah?
Ano yung sinagot ko?
Anong sinagot mo?
1 week,
Day.
1 month.
O 1 month? Sino sumagot ng 2 months? Dapat pala naglagay ako ng mentimeter din. Ilan ang sumagot ng 72? Ilan ang sumagot ng 1 month? Ilan ang sumagot ng 2 months? So, the answer is already here. You have to keep it for 1 month. Okay? Generally, bago mo i-dispose yan, kailangan mo muna yan i-keep ng 30 days. And then, pag after 30 days, wala pa rin growth. That's the only time you can dispose of it and sabihin nyo, no growth. Okay? Now, again, parang nasabi ko na ito dati, yung sa you keep an open pan para lang ma-provide yung humidity dun sa ating incubator. Okay, so maglalagay ka lang ng pan of water kasi kailangan na nila ng moisture and then also the humidity as 40 to 50%. So the general recommendations, you have it here and also in your module, the different recommended incubation times, you have 7 days, 21 days, and 28 days. So depende nga yan kung ano nga yung try natin na i-isolate na fungi. Has actually meron siya nung pati sa type of specimens. So, you have to at least have an idea of what the different media are. Pinaka-importante kasi dyan si chrome agar, si cornmeal, si ascospore. Definitely, pag sinabi mo namang ascospore, ano bang use niya? For ascospore development. Kaya parang kung si dermatophytes, si DTM is specifically for the dermatophytes. si chrome agar candida is specifically for candida. So, konti lang naman yung aaralin nyo. Basta alam nyo kung ano yung mga media na ginagamit pag fungi na ang pinag-uusapan. So, ito yung sinasabi ko earlier, yung sa chrome agar candida, in which makita nyo na kaagad na pag ang nag-grow doon ay nagbigay ng colony color na green, that's your albicans, velvet, is your glabrata. Pag rosea, si cruces, si candida tropicalis will give you now the steel blue. So, specific talaga siya for your candida, and then you can get down already to the species level depending na sa kulay na ipoproduce nila doon sa media. Okay, so ito yung nakatabulate. Anyway, I will send you the PowerPoint naman. So still you have to get into this. Konti din lang yung mga media na yan. So, differential test media, you have your ascospore, your Christensen's, which you will use with your urease test. You have the cornmeal. Also, this is for the identification of Candida albicans. Anong gagawin kasi ni cornmeal? Sporulation. Help niya mag-produce ng chlamydospore. And then you have your cotton seed. Meron tayo ng Zapex. Meron nigger seed, agar. Your rice medium, you will meet later again sa dermatophytes niyo. Your trichophyton, still for the trichophyton species. Your urea agar for your cryptococcus. And the rest. Okay? So, alamin nyo din yan kasi kasama yan sa trabaho natin sa laboratory. Alam natin kung anong dapat media ang kailangan natin gamitin. Okay, so let's get into the different methods for direct microscopic examination. So pwede ka mag-prepare ng iyong temporary mount o ng permanent mount. Okay, for obviously alam na natin kung bakit temporary. And parang gagawin mo lang ngayon for screening or parang preliminary screening, especially your KOH, para magkaroon din ng preliminary diagnosis ang doctor, or we can prepare the permanent mounts. Okay, so we'll get into each one in detail or hindi in detail, overview of each of these temporary mounts. Ano ang sagot nyo dun sa most preferred ba yung question doon? Recommended for your hair, skin, and nails? Ano sinagot nyo?
KOH, ma'am.
Ha?
KOH.
KOH.
KOH, ma'am.
Okay. May mga naka-perfect na. And then, merong kulang kasi 20 lang, 21, at 20 points lang kasi hindi ko inano yung 1. Ay, 21 ba yung total? 21 pala.
21.
Okay. Oo, sige. May naka-20, parang walang naka-21. Hanapin ko mamaya kung ano yung mali ninyo. So, sa line mount, obvious reasons, pag sabi mong sa line mount, ang ginagamit mo lang doon pag mounting agent mo is just your saline. The disadvantage of this is, di ba, ang contrast niyan ipoproduce sa microscope is very low so that ang hirap mag-identify ngayon ng fungal elements. So, we have your KOH, traditionally recommended method. Advantage, meron kang rapid detection of fungal elements. Second is that KOH also tries to clear all of those epidermal cells, leaving only now your fungal elements. And then, you can also try to apply heat para lang mapabilis yung clearing ng mga epidermal cells. Laking tawag doon, frequently ng LPCB na lang. Okay? So, LPCB, ito yung is the most brilliant, pero ito talaga yung ginagamit natin sa psychology. It's very easy to prepare your culture media, the appropriate culture media. Tumubo siya doon, kumuha ka ng colony, then you put it on slide with already the drop of lactophenol cotton blue. Tinakpan mo ng cover slip, prines mo konti, konti lang, either with the tip of a pencil or something that you can use. Avoid using your fingers kung hindi ka naka-gloves kasi syempre mag-flow yung may lalabas din kung medyo napasobrahan mo ang LPCB mo. And then, examine under the microscope. Maganda ang makikita ninyo. Okay. So, anong components ni lactophenol cotton ball? You have your lactic acid, you have the phenol, and then you have your aniline glue. Kaya kung minsan, pag walang LPCB, pwedeng aniline glue na lang para lang ma-stain yung fungal structure. The phenol is the killing agent, whereas your lactic acid helps in the preservation of the fungal structures. So, aside from it being alone lang na nilagay mo sa slide, pwede mo din siyang gamitin sa iyong KOH kasi nga, di ba sabi natin kanina, walang kulay yun. So that you can also try to add it to your KOH prep, parang in-stain mo na din whatever fungal elements may be present in your KOH preparation. Okay, so you have the India ink. You're familiar with this one, the negative staining. Saan ang gamit niya sa mycology is with your Cryptococcus neoformans, as mentioned earlier again. So, kita nyo na kaagad dyan kung paano gagawin. Again, remind ko lang kayo, open the videos inserted in your module. Maiksi lang naman yung mga yun. May 3 minutes, pinakamahaba yata doon yung 5 minutes. Just to give you an idea of how to do all of this kasi nga wala nga tayong face-to-face. Wala tayong practice-based. Pero kanina yung sa webinar ng UP College of Public Health, ang tawag nila is experience-based learning. Okay. So, get into the videos and watch them. Okay, so ito ang ating India ink for Cryptococcus neoformans. Although mentioned earlier din that this has been replaced already by, may gumagawa pa naman, pero more on latex agglutination na or your enzyme immunoassay technique or the cryptococcal antigen na tinatawag na test. Excuse me lang ha, parang may tumatawag lang sa gate namin, sa gate namin. Your India ink or nigrosin. Now, another one, we have the chalcofluor white stain. So, when you have a chemofluorescent or a fluorescent dye, although may ibang fluorescent like your auramine, rhodamine, also is fluorescent, but then its application is different kasi hindi naman siya sa fungi. It's more of your nocardia and for mycobacteria. So, the chalcofluor white is the preferred method. Ano lang ang limitations ni chalcofluor white is that kailangan mo ng fluorescent microscope. Although I read somewhere, I don't know if I still remember it right, pwede naman kasi pwede mo daw siyang examine under the bright field microscope. Pero syempre, we're talking about the pag-fluoresce ng iyong fungi so that ano kaagad natin na dapat ang gagamitin mo ay yung fluorescent microscope. Again, like your LPCB, you can also use this with your KOH. Okay? Then you have now the permanent mounts. We don't really need to discuss into this one, but into this one by one. Kasi you had naman na din your histology. Kasi pag sinabi nating permanent mount, yan yung mga ginagawa sa histopathology laboratory, kung saan yan, usually yung mga tissues or other samples na prepare na natin yan. And then you stain it with the appropriate staining material din. Tapos preserve, siniseal na, may mounting agent ka, and then yung iba, meron din silang ginagamit na pang-seal ng slide. So, you have already your periodic acid chip stain here. Ang color niya, of course, is purplish or magenta. Meron kayong multiple matching type nito. Ano? Meron ba? Sa dami ng quiz na prepare ko, hindi ko alam kung ano yung nasa inyo. Okay. So, sa gram stain naman, this is the hacker modification. So, sinasabi natin dito na all fungi are gram-positive. Now, in your module, pinakita doon na describe doon na the sizes of, like for example, we're talking of the yeast cell over the cocci. Diba? Pareho sila ng shape. And also, pag nakakita ka ng hyphae, kung paano mo masasabi na fungal hyphae dyan, over, kunyari, gram stain mo lang lahat yan. Over naman sa bacilli. So, yung size nila magsasabi na sa atin kung yan ba ay bacteria o yan ba ay fungi. So, anong reagent o ano ang ginagamit sa gram stain when we're talking of mycology or the Hacker modification? We're using now your crystal violet and ammonium oxalate. Know what is the function of each. Now, this is useful for the detection of yeast. Then we have our acid-fast stain, which is, of course, also for your blastomyces dermatitidis. You have your GEMSA, you have your Papa Nicolau, and your HNE. Then the Gomori methenamine silver. This is the one that we always color all of your fungi black. So that it is the best stain for detection of fungi sa histologic section. So pag sinabi natin histologic sections, ano yung mga histologic sections na yan? Alex? Babaran? When we talk of histologic sections.
Hello po, ma'am. Ma'am
Yes,
Ewin,
Alex, good
ma'am
morning.
tissues po.
Okay, you also have tissues. Tissues lang ba ang pwede natin i-histo? Alex?
Ma'am, saka po cells.
Hmm? So, hindi lang tissues, kasi yung tissues, you can also get other specimens that can be prepared in the histopathology laboratory or cytotechnology pa tawag na natin doon. Hindi ko na alam pa anong tawag sa histopath lab. Okay, so your GMS, kasi nakalagay lang dyan usually sa GMS stain, this one provides high contrast with minimal background staining. And again, you have nasa multiple choice nyo yata ito, color black. Okay, so you have the acridine orange for your versicolor. Yung sabi ko nga kanina, it's again a green fluorescent fungal elements and orange epithelial cells. It will give you that. And then auramine rhodamine, you have your Mason Fontana stain. I mentioned earlier when you had your slide on the phaeoid versus your hyaline. And then now we get into the different techniques naman for the microscopic examination. So, alam na natin kung ano yung mga pwede natin gamitin sa temporary at saka sa permanent mount. Now, the technique of preparation naman of that slide for the microscopic examination of the different fungal structures, which you have already learned dun sa first topic natin, sa first lecture. So we do the wet mount, you can do the cellophane, you can do your microslide technique, and your tease method. So wet mount, simple lang siya. Lagay ka ng LPCB, the LPCB sa wet mount. Lagay ka ng sample, nilagay mo ng cover slip, in-examine mo under the microscope. Now what is the problem with this one is that nasisira yung arrangement ng ating spores. Why? From the picking of the colony dun sa ating media to the pressing of the cover slip over the colony. Okay, so pwede natin ma-disrupt yung spores doon. Then you have the tease method. Pag yung tease kasi isipin nyo lang, if you would like to try it later on, kumuha lang kayo ng cotton, yung bulak, kumuha ka ng dalawang toothpick or even if you have your dalawang ballpen, yung point ng ballpen, try nyo lang i-tease. Ang word kasi doon is tease. You try to separate the hibla-hibla ng inyong cotton. That is the tease method. Kasi pag nag-pick kayo ng mycelial colony doon sa ating plate, sa ating petri dish, and then, ilalagay mo doon sa slide mo, you try to separate those hyphae. Kasi mycelium, group of hyphae yung pinik mo. So you try to separate them just to have a clearer view of the structure. Okay? So, ganun yun. Then you again put your cover slip and then examine. So, disadvantage again, syempre ginulugulo mo siya, tinis mo nga siya, disruption of the conidia. So, if you would like to prepare that, kasi kung nag-lab tayo, pinag-grow ko kayo ng fungi, nag-expose lang kayo ng SDA, may tumubo, ginawa nyo ng wet mount, then pwede nyo lagyan ng PVA, and then you seal the side of your sides ng ating cover slip with colorless na nail polish. Then that's considered already your permanent mount. Pwede mo na siyang tignan ulit sa ibang pwede mo siyang i-preserve. I mean, pwede siyang gamitin for future use. Parang ganun. Okay? So, another method for preparation is also the cellophane. Nag-parasite na kayo. Who can tell me how you did your scotch tape method sa parasitology? Hanap muna ako. Giselle. Where's Giselle? Paano nyo ginawa yung scotch tape ninyo sa enterobius? Gumawa ba kayo? Giselle?
No, ma'am. Binasa lang po namin sa book.
Ay, hindi nyo nagawa noon?
Opo.
Naabutan ng lockdown?
Yes po.
Okay. Ano ang idea mo sa scotch tape method pag sa parasit nyo? Doon sa nabasa mo.
Ma'am, yun yung parang sa anus, ma'am, di ba?
Mm-mm.
Opo. Bali yung scotch tape po, ibubukas po yung
Yung pisngi ng puwet.
Opo.
Okay.
Tapos saka na po
Anong kinokollect mo?
yung Enterobius vermicularis po.
Anong form ni Enterobius vermicularis? Anong didikit dun sa yung tape?
Egg po. Ova.
Ova ba? Di ba meron tayo? Pwede
Egg, ma'am.
ova, pwede. Anong Enterobius vermicularis? Yung ba yung pinworm? O yung trichuris ang pinworm? Baka mali ako. Hindi na akong parasit.
Yung pinworm po.
Enterobius?
Yes po.
Okay. Di ba yan yung lumalabas din sa anus pag gabi, ganyan?
Opo.
Okay. So, pwede yun din ang i-collect mo. Ngayon, ganyan din ang principle sa cellophane natin. Thank you, Giselle. Hindi ka nasama sa grupo ni na Kevin, ni LM, at saka ni Jude. Great.
Thank you, ma'am.
Kala ko dadami pa yung grupo nila. Okay, so ganun din yung sa cellophane or yung scotch tape method sa mycology. Yan, napadidikitin mo lang yung aerial mycelia or yung mycelium or yung hyphae na tumubo pataas kasi hindi naman natin mapadikit yung nasa ilalim. Joke lang, ginigising ko lang kayo, baka tulog na kayo. So that with this, so didikit, syempre, yung try nyo din, yung bulak na yan, kunyari, ipatong nyo dyan, lagyan nyo yan ng scotch tape, tignan nyo kung ano yung dumikit doon. So as is yun. And then, lagay mo din siya sa slide na meron ng LPCB. O, dikit mo lang din yung pinagdikitan mo ng mga hyphae. And then again, you just try to check dun sa iyong scotch tape so that you will be able to appreciate potential arrangement kasi hindi mo naman siya tinis, hindi mo naman siya prines. So, kinuha mo lang siya, pinadikit mo lang siya doon, nilagay mo lang sa slide, and then tignan mo na siya. So, hindi nagulo yung o nung mycelium na nakolekta mo. Although, so, pwede nyo itry yan mamaya, kumuha ka lang konting bulak, lagay mo sa scotch tape, tapos lagay mo din sa slide na kunyari may tubig na lang or anything para makita mo lang kung paano yung scotch tape. Okay? So, advantage is, sabi ko nga kanina, wala kang ginulo, pinik mo lang, nilagay mo sa slide, as is siya. Although, the problem there is the contamination. Siyempre, you're picking. Although you have your gloves and all, hindi mo pa rin alam yung sa contamination. And of course, it's just a temporary nature yung pag-scotch tape mo. Eh, hindi naman pwede magtagal sa scotch tape. Siyempre, nabasa na yan, maiiba na rin ang kanyang texture. Parang ganun, matutuyo din siya. Okay, then we have the microslide culture method. What is this microslide? Ito ang magbibigay sa ng optimal examination for preservation of fungal morphology. Nasa multiple choice siya din ito. So, paano ito ginagawa? Go back to your video again. Pero ano lang yan, hindi lang naman siya pwedeng hindi naman bilog yung inyong media. Kaya microslide culture or microculture technique is that hindi mo gagamitin yung buong culture media sa Petri dish. Kukuha ka lang ng konti noon. Ang ginagawa namin dyan is yung mouth ng tube, ng test tube. Yun ang pinangbibilog namin doon, pangkuha namin doon sa ating Petri dish. Okay? Pwede naman din i-cut mo yan into cubes. Okay? Basta siguraduhin mo lang na yung media mo, yung pagka-cut mo doon should be smaller than your cover slip. Okay? Kasi pag nilagay mo na yan dyan sa Petri dish mo, merong, you can improvise, pwedeng hindi L-shape na glass tube, pwedeng nilalagay namin dyan is applicator stick para lang mapatong yung slide mo sa applicator stick. Lalagay ka ng filter paper din pala before the applicator stick kasi lalagyan mo din yan ng water later on to maintain the moisture. Okay, inside the plate. Kung may dalawa ka doon na cut, o pwedeng isa lang, isang na-cut na media, inoculate mo yung 4 sides. Depende sa bawat side niya. Okay, 4. Para makikita nyo dyan sa slide natin ngayon. Then you cover that with the cover slip, then allow it to grow. Okay? Anong ititignan ninyo afterwards dyan? Examine mo yung cover slip, examine mo yung slide. Tatanggalin mo na yung media. Kasi dun mo makikita ngayon, kaya sabi natin dyan, optimal examination for preservation. You can take a look at both the vegetative hyphae and also your aerial hyphae. And syempre, kung merong present na reproductive structure dun, makikita mo rin dun sa iyong cover slip. Okay? So, what are the different considerations when you're trying to identify? Remember that the identification, di ba, sabi nga kanina, you have another identification method for your molds, another identification methods for your yeast. So that when we're talking of the mold, sabi nga natin, if you remember, sabi ko kanina, their macroscopic appearance can already be very helpful. Their growth rate can already be very helpful into their identification. So that pag yan medyo mabagal tumubo, greater than 10 days. Examination ng mga culture ng growth ng fungi usually is that start mong tignan yan at day 3. Kasi ang pinakamabilis 3 to 5 days. And then, at day 3, kung may tumubo, titignan mo na siya every day or every other day. Pero ideally kasi, ewan ko, sa akin kasi pag once may tumubo, tinitignan ko na kung may tumubo pa bang iba na magkaiba ng kanilang karakteristik. Okay? Otherwise, kung di naman wala day 3, day 4, alam mo na mag-spacing ka na. Kasi alam mo na ng slow grower yan. Baka after 1 week pa yan. After 1 week, wala pa rin. After 2 weeks. Basta tignan mo lang kung may tumubo o wala. Okay? Now, for the colonial morphology, pareho lang naman din. Mas madali nga silang i-identify. Kaya lang, I understand dun sa colony texture kagabi, sabi ko, makita kaya na powdery ito? Makita kaya na velvety ito? O ito ba ay, ano pa ba yung mga ano nyo? Mucoid is hindi kayo magkakamali doon. So, ang nagkamali sa mucoid, -5. Kasi alam nyo na kung anong itsura ng mucoid. Pag ni-review ko mamaya yung inyong pre-test. Okay? I can understand kung di mo ma-distinguish si granular ke velvety. Pero si granular kasi, pag talagang nasa lab kayo, makita mo talaga yung kanyang colony texture. Okay? So that, pag ang topography, ito yung sa elevations. Kung nakita nyo yun, yung sa furrowed, ganun, or convoluted, nakita yung lukot-lukot na itsura. So, yung lukot-lukot na walang direction, yun yung inyong verrucose. Pag siya lukot-lukot pero diretso, radiating out from the center, kita yung linya palabas lang na gano'n, na may direction, yun yung inyong rugose. So that yung umbonate nyo, obvious na obvious, si umbonate, umbok. May umbok sa gitna. Okay? That is your slight erase. That is the topography or the elevation of the colony. Now, when you're talking of texture, sa bakte nyo din, so that here you have your cottony. Pag tinignan mo, bakit cottony? Kasi nga because of the aerial mycelium. You have your velvety, well, low aerial mycelium, parang yung sa velvet growth. Ang inaano ko dito yung felt paper. Di ba pag ano yung sa nakita yung felt paper or yung mga pag naka parang velvet growth ka kasi sabi nila para kang si Assurance Day pa naman. Para kang si Nazareno, sabi nila. Ayun yung velvety. And don't forget to go to church if you have means to go to church for Assurance Day today. And then you have also your glabrous, you have your granular or powdery, and then we have the woolly. Kaso ang nilagay ko dun sa choices ninyo, you have mucoid, you have velvety, you have cottony, powdery ang ginamit ko. Ano ano pa yung isa? Granular and powdery ba? Check ko mamaya. Okay? So, yun ang morphologic features ng ating molds. So, you check for the growth rate, you check for colony morphology. Siyempre, pag nag-grow na yan, anong next na gagawin mo? Tignan mo na ano ba ang topography niya, ano ba ang texture niya. After which, you prepare your mount, you do your microscopic morphologic features. Okay? So, ito ulit yung inyong algorithm. Marami na ngayon pag-identify ng filamentos. Meron na rin molecular detection, very few. And hindi ini-entertain, parang dine-develop pa rin yan. I went through some journals into molecular diagnostics ng fungi. Sayang na nahuli yung ating CPH kanina, ang daming researchable topics doon kanina. We can also do serology, that's why you have your filamentous fungi. Exo-antigen, sabihin ko sana. Then you do your macroscopic. When macroscopic, syempre surface pigmentation. This pigmentation is may surface at saka ma-reverse. Through surface kasi pag tinignan mo from top yung plate. Okay, hindi yung hinawakan mo yung plate mo, tinignan mo sa taas. So you're looking at the cover. From the cover side. Pag tinignan mo yung reverse, tinitignan mo from the bottom side. Kasi usually, pag masyadong high yung aerial, marami kang aerial mycelia, nako-cover yung pigmentation ng fungi so that you have to check the reverse pigment. Reverse pigment is examining the bottom of your Petri dish. And then, of course, your colonial morphology. Ano yung colonial morphology natin? Texture and topography. And then, ang growth niya sa cycloheximide containing media. Then microscopic, you have there, you prepare the different mounts. You have your tease mount, you have your microslide, you have your wet mount, or the adhesive tape. Yun ang mode of preparation mo para magawan mo na siya ng microscopic examination. Okay? So, you come up now with two specific characteristic para at least ma-identify mo sa fungi mo. You get into the macroscopic examination and then also the microscopic examination. Now, for the different tests in the identification of molds, we have the hair perforation test. Then you have also your urease test, Tayamine, Trypophyton, growth on rice grains, and more. Now, ang exo-antigen, yan yung sa serology kanina dun sa ating algorithm. Okay? So, commonly, you have the hair perforation or the beating test. What is your hair perforation? So, dun pa lang sa word na perforation, titignan mo ngayon kung kaya bang i-penetrate ni dermatophyte yung hair. Kasi from the perforation test, pwede mo nang ma-differentiate si rubrum kay mentagrophyte o si canis kay equinum. Okay, so how do you do that? Again, go back to your feature, but it's just simple. You get a hair, although usually nga sabi, pwede mo munang whisk-dry ka, nag-fluoresce ba yan para hindi ka kumuha ng hair na hindi naman infected. Ay, sorry, nalito si ma'am. Here, you get ano na ito tawag, sterile hair. Kasi doon mo ilalagay yung nag-grow mo sa plate. Okay? Hindi infected yung hair. Sorry. Correct ko yung sarili ko doon. And, so, you have a sterile hair. And then, nag-grow ka sa media. Kung kumuha ka doon sa na-inoculate mo o yung nag-grow, ilagay mo naman siya, i-inoculate mo doon sa hair. Kasi titignan mo ngayon kung yung fungi mo ba, yung dermatophyte mo ba, kaya ba niyang i-penetrate si hair or not. Okay? So, kasi dyan nga, kung ma-penetrate niya yan, which will be shown in the succeeding slide, siya ay si mentagrophyte. Now, going back to your first, bago ko lang makalimutan, medyo nag-consider ako na with the labeling. But next time, hindi pwede yung nilagyan mo siya ng, meron siya ma'am, spiral hyphae, pero meron pa siyang ascospore, meron pa siyang ganito, na hindi naman pwede nandun lahat sa slide. The spiral hyphae was very obvious in the slide. Doon nang galing yung kanyang macroconidia. Kasi di ba sabi natin, ang mga conidia saan manggagaling? Diba, doon sa mag-a-attach yan sa hyphae mo. Kaya nga, pag yan ay doon sa mga sa sporangium, you do not tell me hyphae, but you should label it the sporangiophore. Parang ganun. Pero with this one, doon sa mentagrophyte kasi, pag hindi magkakatugma yung structure nyo later on, at kunyari ganong slide pa rin, at meron kang sinabi na ang macroconidia ay piriform, kanino ba si piriform? Di ba yung piriform yun yung maliliit? Yung mga parang tear shape. So pag hindi mag-coincide yung mga sagot ninyo, automatic irorong ko na yan lahat. Doon kasi sa first nyo, pag na-mention nyo si micro, si macro, si spiral, 2 points kasi pag nasabi nyo si, nag-ano pa nga kayo, variant in, ano niya, kalimutan ko, kinonsider ko lang lahat mo na yun. You had the microconidia, kahit wrong yung shape na kinabit mo kaya micro o kaya macro, kinonsider ko yun. In succeeding quizzes, pag meron akong nilagay na ganun and then you put hindi magkakasama dapat na structure into one slide, wrong na lahat yun. Kahit nakuha mo ang isa, dinagdagan mo ng hindi naman kasama doon sa fungi na yun, hindi niya characteristic yun, wrong lahat. Okay? Okay, so ito yung sa hair perforation or grating test. So yun, you place your cover slip and then tignan mo nga kung may perforation sa hair shaft. So yan yung nakikita ninyong perforation. Okay, this is a positive hair perforation test which now shows the penetration of the fungal agent in the hair shaft, which is a typical reaction by mentagrophyte. Kapag 4 na ang slide nyo, may ganyan na, iba naman tatanungin ko sa inyo, aside from that, nag-pick ka ng colony, nilagay mo sa slide, ano yung mga nakita nyo? Pwede rin ganun. Okay, para lang ma-recall nyo, ano ba meron si mentagrophyte? Because we're talking of identification. So you should be able to identify ano ba yung mold o ano ba yung yeast na nandun sa iyong mount o kung nandun sa iyong plate. Okay. So you have, again, the different tests. You have your urease test. Pareho lang din dun sa iyong bacteriology. It's just that you're using now fungi. Again, their ability to produce the enzyme urease. Anong gagawin ni enzyme urease? Doon sa ating urease test, if you remember your bacteriology. Sino hindi ko na? Christian? Paltep? Saan si Christian? John?
Ma'am Christine.
Ay, Christine, sorry. Sabi ko siya, nakapikit-pikit ako eh. Bukas magpapacheck na ako ng mata ko. Christine!
Yes, ma'am.
Ano yung function? Ano yung gagawin ni urease? Kasi 'di ba sabi ko, when we're talking of the urease, dapat meron sila ng urease enzyme. Anong ginagawa ni urease enzyme? Ano bang ginagawa ng mga enzyme pag present sila?
They break down.
Anong bine-breakdown niya dun sa urease test?
It breaks down the urea.
Anong bine-breakdown niya si urea? Maging ano? Bakit siya magko-color? Anong positive result natin sa urease test? Nandun yan sa exam ninyo. Sa quiz niyo yan kanina, ano? Hindi niyo na matandaan. Ano yung kanyang positive? So, ano yung ginagawa ni urease? It will break down the
urea, ma'am.
Into rapid urease. Rapid urease. Yung breakdown the urea to ammonia plus carbon dioxide. Si ammonia ang magbibigay ng alkaline, cold alkaline environment. Yun ba yun? Paki-check ha ang urease test. So, this is just to differentiate you. Thank you. Ano yung pangalan ni Christine? Christian. Christine. Okay, it's just to differentiate your mentagrophyte again from your group. For paki-check ulit yung urease test with the molds. Hindi ko alam kung doon sa ano yata yung rapid urease test, magkulay pink siya or pareho lang sila. Anyway, just go over your module. Okay, so Tayamine requirement. When we're talking of requirement, Kailangan ba nila si thiamine or not? Right? Tama ba? Ano na? Si thiamine requirement natin. If you look at our slide, it's a single most useful nutritional test for dermatophytes. So that's here, the tubes of media with and without thiamine are inoculated with a tiny medium-free portion of the colony. Why you wouldn't like to get anything kasi kahit ka-minute lang nung makukuha mo dun sa media, masama dun sa colony mo, pwedeng magkaroon ng effect dun sa result. So that you now try to check for growth after 10 to 14 days. Ano ba ang sinasabi pag ganyang may growth? In bacteriology or mycology, pag nag-grow yung microorganism into something with thiamine, for example, here with thiamine or without thiamine, we have Harley. Si Harley ang lasa nag-in kanina eh. Harley. Lasa nag-in, unang lumabas yata si Harley. Harley, andiyan ka pa? Okay, nawala si Harley. Jamie. Jamie Bello. Jamie? Wala na din si Jamie. Kailangan
Hello,
na
ma'am.
yan.
Hello po, ma'am.
Jam. Ano ba to? Jam? Jamie? Jam.
Jamie po.
Okay, Jamie. Ano yung ibig sabihin either bacteriology or mycology pag nag-grow? Pag may growth ng microorganism. Parang dito sa thiamine natin. When we say observe for growth after 10 to 14 days. Anong ibig sabihin? When we're trying to observe for growth. Bakit siya tumubo? O bakit hindi siya tumubo?
Ma'am, kapag ka tumubo po, ay kapag ka walang tumubo po, ano po,
Jam, taga Isabela ka?
ako ma'am.
Sige.
Ma'am, hindi niya po kapag wala pong tumubo, ibig sabihin po, kailangan niya po ng certain nutrients po para tumubo po, ma'am. Ganun po siguro.
Ginulo mo naman ako dyan. Pag hindi siya tumubo, kailangan niya ng certain requirement para tumubo. So, nandun kaagad yung no growth or with growth. Parang andun na kaagad yung no growth at saka without growth. So, dito hindi. Pag sa thiamine natin, pag siya ay tumubo, anong ibig sabihin? We're talking of a thiamine requirement. Para hindi makalimutan, pag sabi thiamine requirement, kasi may carbohydrate assimilation test, mga ganun. When we say thiamine requirement, ibig sabihin, pag tumubo, kailangan ba yan thiamine? Hindi niya kailangan ng thiamine.
Ma'am, kailangan niya po ng thiamine pag tumubo.
Okay, so ginamit niya yung thiamine, so it was able to grow. Di ba ganun naman lahat ng microorganisms natin? You provide the nutrient that they need para sila tumubo. So ganun yung sa ating thiamine requirement. Okay, so with trichophyton agars, ganyan din siya. We have trichophyton agars 1 to 7 actually ang trichophyton agars natin. So, dinidetermine din each of those trichophyton 1 to 7 na tubes na inalagyan mo na kanya-kanyang magkakaibang supplement. Parang ganun. So, makikita mo ngayon din, observe mo din ng growth yan. Ano mo, saan ba pinakamarami ang growth? So, you're scoring with a scale of 1 to 7. Now, but growth on rice grains naman is, kung makita natin dito, you try to inoculate again yung rice grain, okay, ng colony. Titignan mo kung tutubo na naman siya doon sa rice grain or hindi. Like for this here, we have that canis grew on the rice grain. Si Odini, hindi siya nag-grow. Okay, hindi siya nag-grow, walang growth. Ang ginawa niya instead is, pinalitan lang niya, nag-change lang ng color yung rice grain. Okay? Obvious naman ang growth. Alam naman natin itsura ng mga molds pag yan ay nag-grow. So parang yan nakikita nyo yung mga sa mga items sa bahay na biglang tinubuan ng amag. Parang ganun din yung sa ating growth on rice grains. Now, for the exo-antigen test, di ba kanina dun sa ating algorithm, may serology. So ito yung sa serology part din. Meron tayong specific antibodies that are developed against particular mycelial antigens that will react specifically in a gel immunodiffusion precipitin test. So that ang hahanapin nyo dito would be precipitation bands or precipitation lines. Kasi magkakaroon dito ng antigen-antibody reaction. So I know you have your IS now. Sabi nga ni Sir Jack kahapon, timing yung webinar ng IPCE turo, Sir, kasi it's on the different vaccines. So, ano yun timing daw na yun ang lesson ninyo sa IS. So, pinasali niya. Kasama ba kayo doon? Yung nakinig ng webinar?
Yes,
IPCE
ma'am.
turo?
Yes, ma'am.
Okay, magkakasama pala tayo kahapon sa webinar. Gagaling yun, napasa nyo din yung ng kanyang quiz. Kasi di ba walang certificate pag hindi pumasa sa quiz? Okay. So, yun yung sa exo-antigen test natin. So, ito yung example wherein you see the lines of precipitation. Okay? So, may antigen-antibody reaction. So, for our yeast, again, you take on to the colonial morphologic features. Ito kasi, di ba, ano ba ang colonial morphologic features ni yeast? Diba sabi natin, ito lang yung bibigay ng kapareho ng bacteria where you will see the mucoid colonies din. Kaya na pagkakamalan din usually na bacterial colony. Then we get into the microscopic morphologic features. Ano ang microscopic morphologic features ng yeast? Ano usually makikita nyo? Then there are physiologic studies also and rapid commercial yeast identification test, or usually yung tinatawag din natin na API, wherein it will show you the analytic profile index of the organism. Ito yung maliliit na tubes. Andun na lahat ng biochemical test niya para lang dun sa specific organism. So that you have your different rapid tests. You have your urease production, you have your germ tube production, the presence of a pseudohyphae, a chlamydoconidia, and so on and so forth. So, the germ tube test is, siyempre, if we're talking of the germ tube test, ano ba yung germ tube? Bakit siya tinawag na germ tube? Saan dyan ang ating germ tube? Dapat alam natin ano si germ tube, ano ba si pseudogerm tube, kasi meron tayong true hyphae, meron tayong pseudohyphae. Now that when we talk of a germ tube, ito yung mga outpoaching of the cell wall that becomes tubular. So if you look at the images sa right lower quadrant ng ating slide, and it does not have a constriction at its base. So the base here, when we're talking of bases sa mga yeast cells, yung dito ang base. Okay? Kita nyo yung cursor? Kita ba yung cursor? Yan yung tinatawag nating base. Kasi usually, pwede rin din gamitin kasi yan pag arising from a narrow base or a broad base, mga ganon. So, yan yung base. So, walang constriction dun sa base. So, yan kasi pag nag-out pouch yan, mahaba na kasi yung germ tube niya, constriction, nag-out pouch siya, constriction. So, pag meron kayong din yung hyphae. So that when you see the word links of sausages, that is your pseudo hyphae. So, ang difference ni pseudo-hyphae kay true hyphae is si true hyphae nyo walang constriction dun sa septa, kay dun sa cross walls ng inyong hyphae. Yun ang inyong true hyphae. Kasi nga, pag pseudo-hyphae, sabi nga natin, nagbad, so meron siyang constriction. So, ganun-ganun lang. Isipin nyo lang yung links of sausages. Okay, so how do you do this? The germ tube is a presumptive identification of Candida albicans or also of our Dubliniensis. But it is more specifically used kasi naman ang common usually na ina-identify si Candida albicans. Anong kailangan natin for the germ tube test? You need the use of serum or plasma. If you don't have this one, usually kasi mga nag-expire na plasma sa blood bank, pwede nang gamitin yan. Then it is inoculated and incubated, and then you check now for the formation of your germ tube. Then you have here the procedure. So you can get into your Baileys or also the Mayho. Nandun din naman yan. Or dun sa inyong video na nakalagay sa module ninyo. Okay, again, another algorithm. You just go into it later on para at least ma-memorize nyo. You can put names. You can take out the names. You can draw para nang sa ganun, alam nyo kung ano talaga yung algorithm na yan for the yeast. Okay, so andyan yung pag nag-produce ng germ tube, anong next na gagawin mo? Pag hindi nag-produce ng germ tube, ano naman yung susunod na gagawin mo? Okay, so the different tests again for your yeast, you have your carbohydrate utilization. So ito yung meron siyang API. Ano yung API? This is your analytic profile index, which is most commonly used. And then you also have the chromogenic substrates. Ito yung example natin dito is your Chrome agar candida, and then you can do temperature studies wherein you see that Cryptococcus has an optimal temperature. If you go back again doon sa ating lesson din ng bacte, you have the optimal, then you have the minimum to maximum, mga ganun na temp wherein your microorganism can grow. So optimal temperature for Cryptococcus is 25 degrees, so that at 35 hindi siya masyado mag-grow, and at 42, hindi na siya mag-grow. Now, trying to differentiate your albicans using temperature studies, you will see that albicans will grow at 42, si Dubliniensis nyo is hindi mag-grow at 42. Now, you have your rapid, ito pala yung sinasabi ko kanina, na lito ako dun sa, pero pareho lang naman silang urease test, so that the enzyme urease here will the fermentation of urea, yung kanina, will tawag dito, change your urea to ammonia and carbon dioxide. Yung ammonia ang magbibigay nung, nalito na naman ako. Microdilution plate, you're using your urea broth. Di ba yun kanina sa mold natin, ang ginamit natin, Christensen's urea agar? Dito, you're using a broth. So, microdilution ang ginagawa dito. So, include positive and negative controls. You seal the wells with plastic tape and incubate for 4 hours. And positive result would be pink to purple color. Then, we also have your nitrate reductase. Again, it is the ability to produce nitrate reductase. So, ang procedure, so you sweep the tip of an applicator impregnated with the reagent across 2 or 3 colonies of yeast and transfer in a tube. Incubate the tube and swab at 45 degrees centigrade for 10 minutes. Then you remove the swab and add 2 drops each of your naphthalene, ethylene, diamine, and sulfonilic acid reagents to the tube. And kung present, kung nag-produce yung fungi natin ng nitrate reductase, then you should be able to see a red color. After, of course, the addition of your reagents. And then, you have your levodopa ferric citrate test, which is for your Cryptococcus neoformans, because it produces the enzyme phenol oxidase, which will be made to react with dihydroxyphenylalanine in the presence of ferric acid, so that it will form now a dark pigment compound, which is your melanin. So, I'll just borrow what Sir Wilson told you when he lectured on biochemical tests. Always remember, diba sabi niya yung mga end products, yung mga substrates na ginamit, tsaka yung result niya. So again, you have 3 different tests wherein you will have to remember din their reagents and the reaction that happened. So procedure, you have, the test is available commercially. So you smear the test organism onto the surface of reagent disk, which were moistened beforehand. Sabi nga niya dun sa ating procedure. With 2 to 3 drops of distilled water in a petri dish. Incubate and examine at 30-minute interval up to 6 hours. And you have your potassium nitrate assimilation test, which is the ability of yeast to use nitrate as the sole source of nitrogen. And the cornmeal agar, dito sa cornmeal agar ulit, you check for the demonstration of hyphae. Diba sabi nga kanina natin, there are some agars that would tawag doon, enhance ba or it will help in the production of the different structures ng ating fungi. So the Candida albicans, if you grow it on cornmeal agar, it will be able to demonstrate now the hyphae and the chlamydospore, whereas yung sa Cryptococcus, yung production ng you will be able to see the blastoconature or the budding yeast cell. So you have your 1,3-beta-D glucan detection. This 1,3-beta-D glucan is present in the cell wall of most yeast and molds, including our pneumocystis, except your mucorrheiceous molds. Okay, so there are commercial yeast identification systems. Ito yung mga iba-iba. They may be semi-automated or automated, wherein you have your API-20C, API yeast ident, you have your uni-yeast, automicrobic system, Abbott Quantum 2 system. Lahat ito gagamitin sa ating yeast identification. Now, another identification of yeast in clinical samples. So, another algorithm. And then we have here a table of the genetic targets utilized for the detection of identification of fungal detection and identification of fungal elements. So you have there the gene target, we're targeting for the actin or the beta-tubulin or the calmodulin, cytochrome B, and then also the nucleic acid, we have your ribosomal DNA, at iba-ibang subunits niya. And the susceptibility testing, this I will have to be honest with you. Now, it has always been my dilemma pag nagma-microviro ako. Kasi sabi ko, hindi namin kasi I always try to do things with Ma'am Arlene sa laboratory. We tried kasi madali lang yung antimicrobial susceptibility natin nung sa mga bacteria, di ba? You prepare, how do you do your antimicrobial susceptibility? Angelica or Serena? Za? Ay, ganon? Okay. Ngayon, Chappy? Tam, hindi ka Chappy? Asan si Tam?
Ma'am?
Paano na ulit yung gawa natin ng susceptibility
Ma'am.
testing? Yeah. Okay ka lang?
Ma'am, yes. Ay, okay na raw si Za, ma'am.
Za, game na. Paano yung susceptibility testing natin sa bacteria noon? Oo. Paano yung preparation ng bacteria mo? Okay, so magpre-prepare ka ng bacterial culture mo sa broth. Okay, and then, wag smear, ipe-plate smearing is only smearing is only done on a slide. Okay, inoculation. So you inoculate mo siya sa iyong plate, 'di ba? And then, dapat makakreate ka ng loan of the microorganism. And then, after na inoculate mo yung iyong bacteria, anong next gagawin mo? Asan yung wala yung antibiotic this? Ja. Ja. Hello? O, nag-choppy na. Oo, okay. So, yun ang ano kasi, I have never done antifungal susceptibility testing, in all honesty. I've been trying to read, ito talaga yung dilemma ko nga, sabi ko, Sir Edwin, paano ako di ba usually you spread the microorganism, yung bacterial culture natin sa plate. Magawa ka ng magandang na walang spacing, kaya nga loan ang tawag natin doon. Now, looking into the susceptibility testing din, I read Mahon and then I went into kay Bayliss and then kay Kedelos, walang talaga kung paano gagawin even on the internet. Now, but if CLSI develop, sabi niya kasi dito, dun sa net din, so yung mga macro dilution and micro dilution broth methods, wherein present niya lahat ito yung iba-ibang method or yung document para sa antifungal susceptibility. So you have there bawat document sa bawat gusto mong gawa ng antifungal susceptibility testing. So, pag nakakuha ako ng magandang video or magandang lecture, I'm still trying to work on this one para at least pare-pareho tayo magkaroon talaga ng idea. Kasi sabi ko nga, hindi pa talaga ako gumawa ng ganito. Although in your module naman, nilagay ko kasi doon yung mga antibiotics that are antifungal agents that are being used for the treatment of any fungal infection. So, ito lang ang nandito sa ating slide. And so, doon din sa inyong module, if you went through your module already or if you read a book, but even if you're reading books, please open your Lens account kasi makukall ulit ang attention ninyo at ikukall din ang attention ko, sasabihin sa akin na yung estudyante mo sa D170 hindi nag-open ng kanilang lens. Okay? So, get into your lens pa din. And again, yun nga, I will not be posting in the GC for activities that may be posted doon. Basta check nyo nilang, bigla nilang may activity kung meron. So, ito na yung iba-ibang description, iba-ibang documents. So, the Chevy M27A3, sabi nga dyan, covers requirements for use of the broth microdilution method for testing of Candida species and Cryptococcus neoformans. Now, one thing that I read about this is yung problema kasi sa breakpoints. If you remember the breakpoints, ito yung points wherein you will be able to differentiate the susceptibility ba or resistance ng pathogen. Pathogen na lang sabihin muna natin. Kasi kahit sa bacteria, di ba, you have a breakpoint. Ito yung point wherein masasabi mo na siya ay resistant or siya ba ay susceptible. Ito kasi ang parang naging problema din when we're talking of antifungal, what I read with my Mycology online yata yun, with antifungal susceptibility testing. But if you can help me get into the internet, since if you have more time and you have anything to add or to share with us with regards to antifungal susceptibility testing, that would be much appreciated. Okay? So, yan yung mga iba-ibang documents ninyo. So, like your M38A2, then yan naman siya. For molds that cause invasive and cutaneous infections. Ano yung mga organisms nandyan sa document na yan. Yan ang ipa-follow ng antifungal susceptibility So, gano'n na lang siya. Antimicrobial disc, yung ating disc na nilagay dun sa ating plate, yun ang magdi-diffuse into the media. Na yung diffusion niya, di ba, the farther it travels away from the disc, the lesser the concentration na. So, hindi ko alam kung paano din siya sa mga fungi. But syempre, pareho lang yung action niya kasi ganun din naman si antifungal agent, di ba? It will try to eliminate the fungi. It will try to kill the fungi. So, ganun din siguro yun. But again, if any one of you get into something about it, meron kang makita na study or meron kang makita na notes or meron kang makita na video, please share with us. Now, the e-test, you know what the e-test is? Di ba ito yung may strip na ilalagay mo dun sa after you have inoculated the plate. Merong strip. Yung strip, merong gradient. Magpapakita dun kung bibigay niya sa'yo yung MIC, yun sa kung saan sila mag-meet at the bottom. Yun ang kanyang MIC. Then we also have the sensitizer yeast 1 and the VTEC 2. So these are, sabi niya, simplified. I don't know how simplified they are. So, na alternative methods for our antifungal susceptibility testing. So, we're down to the last slide. This is, ito yung e-test, kung matandaan nyo din sa ating bakte noon. So, yung naka-arrow, yun yung kung saan nagmi-meet and then you check the value that is there, kung ano yung saan siya tumapat, yun ang kanyang MIC. For here, nakikita parang hindi ko masyado makita, blurred siya, pero sabi niya dyan nga, Candida albicans, the MIC is 1 mcg per ml. Okay, so that's the minimum inhibitory concentration of for Candida albicans. Nung nandyan kung ano yung ECY, ano kayang FLC, hindi ko na matandaan yung mga code ng antibiotic. O antifungal pala, antifungal. Okay, so that's the end of my slide yata. O tama, the end of my slide. So that a recall may be posted earlier